So we're going to switch gears a little bit. So Tomáš from Orange is here to talk a little bit about their journey from RESTCONF to NETCONF. So Tomáš, over to you.
Thank you.
Clicker's on the table.
Okay, it's ready. Can you hear me? Yes, good, it's working. So good morning. Dobré ráno in my native language, because I saw some folks from Slovakia yesterday and today. It's still the morning despite several interesting sessions, so wait a bit before the lunch. So today I would like to share with you the story of our journey from RESTCONF to NETCONF and the NSO. So I represent a team of people which is working on that, and I'm responsible for just smart part of it, but wanted to present this topic to you. So as I said, I will discuss several topics. One will be that I will start with introducing our network disaggregation project. Then I will touch briefly, the first experience with the RESTCONF and the NSO that we had. And then, I will continue more and elaborate on the NETCONF and where we stand now with that. And then, at the end, some wrap-up, where we are and what are the next steps. So where we started? It started, I think, at the beginning of last year, when there was a decision that, can we move as Orange from pure networking operating company to some hybrid mode, when we were also delivering network services, but also on the other side, we are able to contribute to the software and also improve some networking software to be more flexible. And in fact, this was one of the main drivers for us, why we started this, that we wanted to have higher flexibility in the hardware and the software. And that's why we decided to make our hands dirty with the disaggregation. And for this purpose, we decided to start with the switch, which was in fact quite simple use case. The purpose was to start with the switch, which is in front of our PE, and it's aggregating the customers. So after some research, we decided to select Sonic, which is an open source network operating system, which was started as a project by Microsoft in 2016 by Microsoft, and the main purpose was the data centers. For the hardware, for the moment, we selected edge core switches with standard setup of 1 gig, 10 gig ports, and 40 gigs or 25 gigs for the uplinks. And one of the more important questions for us was, as we have NSO in our ecosystem for a couple of last years, and we are using it for service provisioning, can we manage also this disaggregated switch, and especially Sonic with NSO, because it would make our life much more easier, because we know how to deal with the other devices, and it would also fit, as I said, to our ecosystem. So what we have with the Sonic right now, there are only two options in the standard code. There is GNMI and RESTCONF. As we have not much experience with the GNMI, we decided to start with the RESTCONF, as on one side it's a protocol which is using the HTTP standard set of methods like get, put, post, patch, delete for the configuration manipulation, and as well you can get the operation data for using it. And it was also on the other side, it's quite easy to start. You don't need to have any programming knowledge, any library. You can just take your CLI, use curl or Postman if you prefer some graphical interface, and really start to play with, so sending requests, getting data, pushing data, and so on. But we started to see the first challenge then, which was that there was no native NSONet driver for the Sonic. But thanks to the Cisco team, which helped us a lot at the beginning, was that they created a customized / experimental net for us, which was based on the Java, because there we needed RESTCONF client to communicate with the Sonic. So they created a net for us. There was a RESTCONF client working fine, I would say. But what we saw with them, that the implementation of the RESTCONF in Sonic has some drawbacks. There are some issues. So we needed to create like specific device profile in the Sonic to overcome these issues. So that was a bit not perfect, but we could live with it. But also what we saw that when we started this project, we were still using NSO 5.2, and last year we migrated to 5.7 train, And also, during the migration, we saw that the initial net that was created for 5.2 was not working for the 5.7. So again, we need to discuss, work together, and create a new version of the net that's compatible with the 5.7 and still working with the Sonic. So despite all these issues, okay, we reached the state when the net was working fine, and we can start some testing of the net and also the switch itself, or the Sonic software, to be more precise, which means that, okay, we push some config on the device manually through the CLI. We did the sync from to see if the parsing is correct, if we can see the values, at least for the part of the configuration we were interested in, so mostly the VLAN and ports and descriptions for the VLANs and ports and so on. And of course, we did manual testing of the reverse, so having configuration done manually in the NSO and then pushed to the device. Okay, the first results were quite positive, so all was working fine. So that means that we started with a creation of the service. So okay, in the team we worked on the service that was doing as I said, this provisioning of the customer VLANs. So mostly the focus was on creation of the VLAN, assigning downstream ports, assigning upstream ports, doing some changes of the description, and maybe sometimes if customer is desiring to do some changes on the port, so if it's auto-negotiated port or it's fixed with some fixed speed and so on. Also, what was good that thanks to the implementation of the RESTCONF, we were able also to get the operational data. Just we needed to specify for the NSO action the RESTCONF path where the operational data are located, which we want. Okay, perfect, working. But RESTCONF is fine, but what if we could switch to NETCONF? As this is the NETCONF protocol, for me, that was really created for the network device management, and it was tied with it from the day one, because that was the purpose, to manage initially the network devices. It's using the concept of the RPCs, with some own messages which are defined, but especially there are some concepts which are implemented in the NETCONF which are missing in the RESTCONF. So mainly what we like is this logic of the different data stores, locking. We can do the rollbacks. And also, once we move on, and we will have several devices that we need to touch in order to deliver the final service to the customer, there is this concept of the network-wide transaction, which is a really good idea, which we can have with the NETCONF. So, can we switch to NETCONF with the Sonic? Unfortunately, not at the beginning, because, again, as the main issue was, as I said at the beginning, there are only two protocols in the Sonic which are available right now, and that was, as I said, RESTCONF and the GNMI. So that's why there was a decision that, okay, anyway, we have a team that's working on the improvement of the Sonic and adding the features that we need, because as it was designed for the DC, for the service provider environment, some features are missing. So anyway, we are working on the improvement. So let's try to do a NETCONF from scratch, implement it, and the implementation is done in Go. So okay, we can start with it, let's work on it, because then we can benefit from the NSO features that are, from our point of view, the three main ones. That we can use built-in NETCONF builder tool in the NSO to build a net anytime we want, and we have really a flexibility here. So, which means that, okay, if we will migrate to another NSO version and the current code is not working, okay, there is a NETCONF net builder tool which is tied with the NSO version, and we can, on our own, rebuild the net, put the young models, and it's working. That's what we tested, and it was really okay. Also, another point was that, okay, there is no Java, as in the team we have no experience with the Java, so it was really much better for us that we don't need to think about Java in case that we need some tuning. So in the perfect world, with this NETCONF net built by the NSO, we'll just put the new young models if there is some change, and everything should work. And the last point, that we expected that with the standard NETCONF interface, we will not need any specific setup. So everything should work as out of the box without any specific tuning. So what was the experience? So we worked on the NETCONF implementation. Okay, there was some steps to some releasing some internal builds. And once we reached the state of some kind of alpha release, that it was quite stable and working. Then we started as a second team to test it, and we saw that it's we could build an NED quite fine. There was no problem. We could build it. Then the question was, okay, what about the service that we deployed? Will it work using NETCONF? And then it was quite surprising that yeah, it's working fine. I believe there was no change was needed in the service code to make it work with the device over the NETCONF. So this migration or change or transition was fully transparent, which was great. And also, if we add the operational data or the models with the operational data, we can access them. Perfect. But okay, as I said, so as we started from scratch, for sure, okay, there were some challenges with the code implementation. Here I'm just listing only the three, I would say, main issue that we faced. First one, that okay, if we needed to change, to push the config only for the VLAN or for the port in two separated requests, it was working fine, but not in the one. So when the service was pushing changes in two different YANG models, it was not working, so we needed to fix it. Another interesting issue was that if in the model was a list of the elements and service wanted to modify several items in the list, like description on 3 downstream interfaces, this was also not possible. Okay, fixed. Another one which was important for getting especially the operational data was the ability for the server to reply to NETCONF request to return the elements from the list even without specific filter. So that was for the issues, and maybe now touched a bit more about the testing, because this was with the NETCONF we evolved it. So with the first release of the NETCONF server, we started with the manual testing. So the same level as we did with the RESTCONF. So changing the config on the devices, seeing if it's reflected in the NSO, and reverse, changing something in the NSO, seeing if it's pushed correctly to the device. But then thanks to the Cisco team and the people, they advised us to use a NSO package, which is called DrNet Examiner, which is part of the program which is on the slide. It's called Network YANG Automation Testing. I'm listing the links because for me, really, this tool helped me. So especially if you are working with the NETCONF nets or the one or with NETCONF devices using the own NETCONF nets, I really advise you to look at it and try. For us, it was one of the success that this tool helped us to identify the issues that we saw during the manual testing, but also several on top. So then, okay, it was like a good reference that it's okay, it's even better than our manual testing, which means that in the next iteration of the server code, when it was delivered, okay, we did again the set of manual tests, all was working fine, and then we were waiting for the DrNet to see, okay, how it looks from its position, and all was fine. So perfect. Here on the slide, you can see now okay, that I'm not doing any demo. There is just a static slide showing you the output, because okay, the way how I used it was that on the device, we will configure some valid configuration states, so modification, creation of VLAN, assigning of the port, for example, and then on the NSO side, after sync from, you will use DrNet to save the state, to do some kind of snapshot, and then okay, you will do any additional, do some changes on the device again, and you will create another snapshot, and then the goal of the tool was to test the NETCONF server implementation, including the NED, using the transition between all of these valid states. So here in this example, you can see that I created 11 different states, and which gives me in total 110 transitions of the switch. There is a list of, okay, transition 1 of 110. It's also displaying you, okay, if you correct name the state or the snapshot with some nice name, it will also help you now in this output to see which part is not working correctly. And at the end, you have the output if it's okay or not. Here, I think this 110 test took with the Sonic switch, I think around 22, 25 minutes. So not so long. So I'm step by step coming to the close of the talk. So as as a success of this journey from the RESTCONF to NETCONF, I would say that okay, we give a go for the service provisioning because we have the implementation of the NetConf server in state, which was okay for the service provisioning. So it was fine for us to start the pilot phase. Then also, as I said, so we will now use this .NED package on the regular basis, that once we have a new release of the NetConf server, on Sonic release with the new code in the NetConf, just rerun the test and to see, okay, still everything working fine. And in addition to this, there is a PyTest script created for some deep dive scenarios of the NetConf to better catch some possible other issues. One important point is that okay, we are planning that okay, once we will reach some kind of full stability of the NetConf server, that the goal is to okay, to put it back to the community that everyone else can leverage from what we did. So it means that okay, our overall feedback from this testing journey using NSO and the packages and .NED and NetConf Builder was really positive, despite the few issues that we had on the path. So what's next? So now we know that NetConf is our target not only for the Sonic, but also for any other possible devices that will come into our ecosystem. As I said, so in last month we started the pilot phase. All is installed in the production, and now we are onboarding the first customers. Also, thanks to the positive feedback or experience, we used the NetConf Net Builder of the NSO for creation of another NetConf Net for another device, which is a 6-pin in this case, which we will try to test and operate for different purposes, for different customers. And as I said, even before that, .NED will be also part of the pipeline testing for any releases. Okay, so that's briefly all. Any questions from the audience? Do we have something? Good.
First question, so why the choice of Golang over Python or Rust or anything?
All in the Sonic is created in, I'm not saying all, but the core functionality is already in Go. So it was almost only the choice.
It was just a simpler choice at that point?
Sorry?
It was just simpler to stick with?
Yes. Okay. I mean, for the Go, it's already, all the interfaces are prepared, so it's prepared for that.
Okay. Second question, I think you actually just addressed on the slide. So the NetConf server, are you planning to upstream that?
Yes, we will. As I said, so there is some internal process. There are still some issues that we have. Okay, they are not important for the pilot because we can deliver the service to the customers, but some other features which are deep dive are still not working correctly, and we decided okay, we'll fix them because okay, Sonic will not be used only by other people, only with the NSO. So okay, let's it more robust, more stable, that even if you will use any other client with the NetConf, which is expecting that this might work, really fix it before the final release. So in terms of date, okay, I think it will be Q4 this year at best.
Okay, cool. More questions on the server. How many people were involved? How long did it take? How often do you have to go tweak the code and make changes?
For the NetConf server, I believe there are only 2 people that are working on it. I mean, the team is bigger, but they are working on the other features. But for the NetConf, there is one primary contact, one as a support, and then for this kind of testing with the NSO, we are just small sub-team of probably 2 or 3 people.
Okay.
And with this for the NetConf, we started, I believe, in September, October.
Okay.
Work on it. Before we working on the RESTCONF part, and I know, I think guys started in October, and then I started to help them on the NetConf maybe November.
Okay, cool. So what are the supported parts of configurations covered by the NetConf server?
Again, please.
So the NetConf server, what parts of the configuration are you supporting?
For our use case, we are using only. I mean, the configuration itself should be for all. The NetConf server is accepting all the models that Sonic is providing. Okay. But for our use case, in the net that we built, We are using, I think, 3 configuration models and 2 operational models.
Okay, cool. And then how many devices are using the NETCONF server, and how do you handle load balancing?
Oh, for the moment, I think the pilot is starting with 5 devices.
Okay.
And I think there will be, I'm not aware of any plans for the load balancing, so it depends, okay, which customer is selecting which access side, it will be provisioned on that switch and corresponding P.
Okay, very cool. I think that is it.
Okay.
Great session. That was very useful information.
Thank you.
Thanks, Tomáš.